Hello, I'm Jeff Kaiser. I'm the U.S. Seed Treatment Technical Service and Product Manager for Nufarm. Today, we'd like to cover Nufarm seed treatments as it pertains to nematodes. We'll cover the current situation in both soybeans, corn, and cotton, and also a little bit about a new nematicide, Trunemco, as a solution to the issue of nematodes in those three crops. This is patented nematode technology, and we'll also speak a little bit about handling of this new product. Nematodes are a widespread problem. They are present across key growing areas that cause yield drag through the damaged roots in the crops of soybeans, cotton, and corn. There's an estimated $10 billion loss in U.S. yield annually from this pest. The time for a better solution is now. Three reasons why new nematode technology is needed is: one, the issue of escalation. Nematodes will continue to spread and intensify in key U.S. growing regions, resulting in further yield loss. Two, the solution that we currently have in resistance, especially in soybeans, nematodes are starting to overcome that resistance that we find in soybean varieties. And three, there are limited choices. There are a limited number of effective seed-applied nematicides protection options available to the grower today. Let's look at the scope of nematode species, their activity, and key target crops. So in soybeans, we're going to look at soybean cyst nematode, reniform, and root knot. Looking at the cotton crop, root knot, reniform, Columbia lance. And then in corn, the nematodes of root knot, lesion, lance, sting, and needle. So let's key in on the soybean crop. If we look at the soybean crop, the current soybean cyst nematode situation, which is the highest, most prolific nematode in soybeans, we continue to see it expand across the U.S. The soybean cyst nematode is very aggressive, and then we're seeing it overcome some of the soybean varieties that have a resistance built into them. And we're also finding that there are low grower awareness to nematodes in soybeans, as the belief is that the resistant trait is controlling the pest. So let's look a little bit closer. The soybean cyst nematode is adapting to the PI 88788 trait. How are we finding this out? We're finding this out because we're finding the frequency of the soybean cyst nematode populations are increasing near 10% of reproduction. And when this is increasing, we understand that the resistance to the trait is starting to grow. This is why our soybean cyst nematode populations are continuing to increase. The reproduction of the soybean cyst nematode is increasing in light of having the resistance of PI 88788. In this chart, we can notice that varieties are decreasing in yield because of this, and what we find is that in the incidence of soybean cyst nematode reproduction, the reproduction is low. We're finding that our yield potential is 60 to 70 bushel, as we would expect. But as that soybean cyst reproduction increases to near 40 to 45 count, we're finding that we can lose almost 14 bushel per acre due to this additional pressure of nematode on the soybean plant, even though that we have the ability to have the resistance built in. So now that we know of the resistance trait and the ability for the soybean cyst to proliferate, we need to look at the management recommendations that we currently have for soybean cyst nematode. Initially, you should test your fields to get an idea what your levels of soybean cyst are in your particular farming and growing environment. The testing should be done or could be done all season long, but the best time to test for soybean cyst nematode is in the fall prior to planting soybeans. So if you could pull your soil samples in the fall prior to planting soybeans, it will give you the best idea of what your soybean cyst nematode pressure is for your upcoming growing year. The second component is to rotate to resistant varieties in soybeans, is what tools we currently have to work with. So if you're currently growing a specific variety, we need to look into making a rotation in that to help with the offset of the increase in the soybean cyst nematode. Third option is to rotate to a non-host crop, like planting corn, so that we can rotate from soybeans to corn to try to reduce the amount of soybean cyst nematode. And finally, to utilize both the trait and a soybean seed treatment product that has nematode activity is another management opportunity that we have to increase our yields and reduce the amount of soybean cyst. Moving on to cotton. In cotton, primarily the highest damaging nematode present in fields where we're growing cotton is the root knot nematode. Root knot nematode attacks cotton in irregularly shaped areas in the field, which will stunt the plant growth, and it makes several of the acres non-productive in that we have a lesser stand and plants that are less vigorous to maximize our cotton yield. Later in the season, these areas that have less than plant stand have the ability for additional weed pressure, which again will reduce our yield. Reniform nematode is a second nematode that's fairly prolific in cotton production. Reniform nematode initially is not as severe as what root knot is to the plant, but it does reduce plant heights and reduce plant vigor to the extent that we will see a yield reduction in the areas where the reniform nematode is present in the field. Therefore, our cotton production is reduced. Reniform nematode signs after it's infected the plant will actually have a kidney in shape on the root itself. The anterior part of the body is embedded into the root and the posterior to the outside, as shown here in this picture. So in summary, there's a 4-year summary of nematicide use from Dr. Kathy Lawrence that encompasses the root knot and reniform in pressure in cotton, 70% decrease in reniform eggs per gram of root with the addition of a seed treatment nematicide. There's also an 18% increase in yield with a seed treatment nematicide across all varieties. So a very positive response. And finally, an increase in seed cotton yield of 577 pounds and also an increase in yield of 152 to 1,336 pounds per acre in yield in cotton where we used a seed applied nematicide. Moving on to corn. Corn as it pertains to nematode pressure. Corn nematodes, in contrast to soybeans and cotton, there are many types of nematodes that can damage corn. Corn nematodes occur in every soil type, not just sandy soils. And the corn nematode damage is common and frequently misdiagnosed as potentially a lack of nitrogen or potentially lack of fertility. With corn nematodes, as shown in this photo, root knot, lesion, lance, sting, and needle are present and are very prolific in our corn growing areas. You can see here in this field as the low-lying areas where the nematodes have extreme pressure in this cornfield. As noted at the bottom, the farm average of this cornfield around 180 bushel per acre, and the yield in the small areas where the nematode infection was high was as low as 30 bushel per acre. So as we move to the underground symptoms on the root on corn with the nematode pressure that we spoke of earlier, we can find on corn roots the chlorosis or the yellowing of the root. There is stunting of the plant above ground that we can see. There's actually dying root below ground. There's an uneven in the overall plant height from the feeding from nematodes. And later in the season, there can be uneven tasseling because of the stunting effect from nematodes early in the season. And in the end, yield loss from the nematode pressure in corn. So as we look here in the cornfield, two nematode pressures come to mind. Needle nematode damage here to the left, and then sting nematode damage here to the right. As we look here on the left, the needle nematode damage taking the root hairs and the root forks away from the root mass, providing a plant that is less vigorous, yellow, and also stand reduction in some areas where the feeding is severe. And to the right, severe root galding from sting nematode, also providing an environment for a loss of stand in a less vigorous plant. With corn nematodes, there's a fairly large amount of nematode pressure that we can find on corn. Nearly 13 different species of nematodes can provide a yield reduction to our corn crop. And as seen here in this chart, there is a low, moderate, and high range for each species of nematode and how it can affect the yields in that particular corn crop. In addition to the nematode index, we need to keep in mind the ideal timing for nematode sampling for corn is prior to the growth stage of V5. When we are sampling corn, we need to not only grab a soil sample, but we need to be able to be probing through the root mass below the plant so that we can pick up the count of the nematodes that are listed here in this graph to get an idea of what pressure that we have in our specific field from this nematode, the nematode pressure we have in that growing environment. So our corn nematode management program. There's no known resistance to corn nematodes in the current varieties that we're able to source. Second, seed treatment applications do provide an early protection against nematodes when the seed germinates, and it also allows the plant to get a head start against any nematode feeding that would occur in that early growth stage. Rotation, there's no known effective rotation for nematodes in corn. Weed management, particularly grasses or perennial grasses, are a good host and keep the populations of nematodes high in a given field. And finally, plant health management to minimize yield loss, along with managing nematode pressure. That is part of the program that will help you be successful in both nutrient management and obtaining higher yields in irrigated fields. Nematode impact on corn. The nematode damages to corn is not well defined as we look at the corn plant above ground, but as we diagnose more of our root damage and do more below ground, we can find how much damage the nematode is actually doing to our crop. Some organophosphates that are used for chemical control in our corn crop are not as widely used and available as what we have had in the past due to other herbicide options and the flexibility of what corn that we're currently growing. There may be more damage being done than growers realize, because if we're not going below ground and analyzing our root system, we may not know how much damage we are receiving from the nematode pressure that we have in a given growing field. CRW traits replacing the in-furrow insecticides in the corn rootworm areas may have led to some increase in nematode awareness, because we believed at that time the CRW trait provided complete protection below ground, which in fact it was targeted only at corn rootworm. More corn on corn and reduced tillage is a great environment for increasing nematode pressure for current growing conditions. And finally, the ROI with the higher price of corn that we have today and the yield expectations are higher, helps with the message around nematodes that there's additional yield and ROI available by focusing on protection to this particular pest. So we'd like to touch upon Trunemco. Trunemco is a solution for those pests that we have spoke of in both corn, cotton, and soybeans pertaining to nematodes. Why would we look at Trunemco or a seed treatment for the protection against nematodes? One, it's targeted timing and application. The pests are vulnerable early. The seed treatment provides this protection as early as the plant germinates. And when we apply it to the seed, we protect every seed every time. We cannot repair stand loss after it occurs, so this protection early is extremely critical. The other thing about the early protection is that we will also lessen the effect of stand loss from disease through the ports that the nematodes create in the root system, and also lessen the amount of insect feeding on the stunted plants of poor health. Minimal effort to gain the control. The ease of utilizing a seed treatment nematicide is very easy, as it is effective as soon as the seed is planted and the seed begins to germinate. And it is a very positive return on investment. With Trunemco, we've seen an upwards of 14 bushel yield response 60% of the time in corn growing areas where we've had nematode presence. And it does support and protect the host plant resistance, providing protection to the plant. So let's look at the activity of Trunemco. Trunemco primes the plant's physiology. That's another way to manage nematodes, is by stimulating the plant's genes that are responsible for several defense components in the plant. These include genes that regulate and increase the cell wall components, genes that regulate and increase compounds that are naturally toxic to nematodes, and also genes that are responsible for regulating the plant's hypersensitive response to nematode infection. One of the primary ways that Trunemco is effective is of the control through the direct impact to nematodes within the plant. While there are several modes of action involved, we can directly impact nematodes with the impact of Trunemco by directly reducing the population of nematodes early in the life cycle of the plant, and consequently reducing the amount of damage the plant incurs from nematodes. A second mode of action, another environmentally sound method of nematode management, is to supply the plant the ability to have the colonization around the root. So as the plant continues to grow, Trunemco is able to provide a colonization around the root to provide additional protection to that root as it grows, protecting those root forks and root tips against nematode penetration. So in review, true nematode confidence from Trunemco starts with priming the plant with the new patented technology, activating the natural nematode barriers that optimize the protection early. Secondly, it defends the plant with the biochemical and microbial actives to provide a dual defense, inside and out, against nematode feeding and establishment. And finally, it allows the plant to thrive, protects against nematode damage while supporting root health and seedling vigor to help plants thrive, delivering higher yields. So with Trunemco priming the plant, we utilize the cisjasmone component. Trunemco physiologically induces and changes that resistance to nematode establishment early with the power of cisjasmone. It strengthens the cell wall barriers, it increases in nematicide toxic defense chemicals within the plant, and it increases in hypersensitive triggers to help provide that initial protection against nematode as that plant germinates and establishes itself in the growing environment. It also impacts in the penetration and internal establishment of nematodes early and prevents overstimulation of plant defenses. Specifically on priming the plant, there's two ways of influencing the plant early. One, a systemic acquired resistance, which most plant growth regulators that affect later stages in the plant have the ability to go that pathway. And if we look at the pathway of induced systemic resistance, this is where the jasmonic acid within Trunemco helps build the defensive mechanisms within the plant to provide that defense against nematodes early on. The defending attribute of Trunemco is stimulating the resistance gene expression that is repressed by nematodes. So as we look here to the left, the typical expression within the plant for nematode protection is established at 100. And once the plant is exposed to nematodes, that mechanism is repressed to near 40%. As we introduce Trunemco to the plant, we're stimulating the plant 80% more than what it normally has to provide that initial gene expression to defend against that early attack of nematode. Trunemco provides a secondary form of defense with the plant. The second form of defense comes with the Bacillus aquamillifaciens that's provided in Trunemco once it's applied to the seed. Trunemco defends through this biological activity, providing a protective barrier to the root system as it's expanding and growing as the plant grows. This physically reduces the number of available penetrating and feeding sites for nematodes as the plant's growing. And it also increases the production of defensive secondary metabolites, creating that additional protection for that plant growth. So with Trunemco, allowing the plant to thrive by helping with protection of the root, increasing the shoots and yield of a given plant from the protection it provides against nematodes, Trunemco's impact on the nematode development is arrested early. So the availability of feeding sites on a given plant are reduced because of the protection of Trunemco. The resistance to the establishment of feeding sites is increased because of the use of Trunemco so that the nematode does not feed on the root. Nematode injury is managed, so there is a reduction in the damage from the direct penetration and colonization of nematodes in the given root system that has had the Trunemco protection applied. There's also a reduction in induced strain or plant resources so that the plant can focus on adding additional yield later in the season. Also, there's a reduction in secondary disease development because we've reduced the sites, the damaged sites from the nematodes so that we're lessening the amount of infection portals that the plant has in its root system. So as we look at implementing Trunemco as part of our nematode solution, one, the worker safety with Trunemco is very high. 2, the convenience of utilizing this low rate technology will allow us to add it to our main slurry mix. And 3, it's very compatible with all of our seed treatment offerings with corn, cotton, and soybeans. The thing to keep in mind is that there is a low use rate of Trunemco. The use rate is 0.3 ounces per hundredweight. The signal word for Trunemco is caution, and it is compatible with most all seed treatments for corn, cotton, and soybeans. So let's review the use of Trunemco as a product as we're looking to add it to our seed treatment slurry mix. 1, we need to keep in mind that Trunemco needs to be added to our main chemistry slurry. Using a carrier will help ensure distribution across the entire volume of seed being treated. Keeping the slurry mix under constant agitation will help ensure that all seed is treated equally. And finally, we need to keep in mind that Trunemco is designed for the main slurry tank. That is not recommended to be used in the inoculant pump system, as the pump and tank system for inoculant application are not accurate enough for our low use rate of 0.3 ounce per hundredweight. And finally, the required PPE for Trunemco is for the applicators and handlers must wear long sleeve shirt, long pants, waterproof gloves, shoes, socks, and protective eyewear. And in the instance where we have a totally enclosed treating system, we will be able to waive that PPE requirement. Thank you.